Okay. Your attention, please. Now, let's go over the quiz. Better, but still not where we need to be. Is she? Like this. Okay, so let's do it here first. Then we'll go to the quiz, and then we'll come back to the rest of the lesson. Write the equation of the line, whose slope is 3 and whose y-intercept is 4. That should be really easy. Y equals 3x plus 4. Remember, it's y equals mx plus b. It's a lousy looking x. M is slope, b is y-intercept. So that determines where I put the 3 and the 4, yes?
It's minus 4 because it's a negative 4.
Oh, is it minus 4? Sorry about that. Thank you for correcting me. Minus 4. Okay? First one, very simple. Next one is a lot like a question that was on the quiz. So we're going to do it now, and then we'll do it again in a minute. It says here, write the equation of a line that is, key word here, parallel to this line. Now, what do you know about parallel lines as it relates to equations of lines?
That the slope is always
The
parallel?
slope is always the same because it's parallel. So therefore, the slope of the new line will be 2. And then it says it has the same y-intercept as this one, Rach? Y-intercept has to be 3 because it has to be the same. So again with y equals mx plus b, we talked about this the last couple of days. Y equals box x box. The first box is for slope, that's 2. Second box is for y-intercept, that's plus 3. So y equals 2x plus 3 is the correct answer. Yeah, you got all the hard ones right. And then this one, which is not easy, but there were harder questions on the quiz than this one. And this one you didn't get right. I was surprised. Okay, next. Write the equation of a line that passes through 2, 0, and 4, negative 5. 2, 0, 4, negative 5. Okay, so what I notice is when I look at the slope, I notice that we go down 5 over 2. So if I want to work backwards, I'm going to go up 5 and 2 this way. So here's my line, all drawn in. Mr. Tello, this will be your last bathroom pass for quite a while. So make sure you take care of it at lunch. Now, y equals mx plus b. Y equals box x box. Who wants to tell me one of the boxes? Go ahead.
Negative 5 over 2.
Negative 5 over 2 is the slope, so I put that in there. Now, the y-intercept we have to judge by looking at it. What is the y-intercept on this one? Mr. Roach, I want to take your attention away from your cookies for just a moment. What is the y-intercept?
Y-intercept is 1, 2, 3, 4, 5.
5 it is. And make sure you mention that it's a positive 5. So y equals negative 5 over 2x plus 5. Any questions? Okay, we should be growing pretty comfortable with this kind of stuff. Your next test is going to be loaded with it. Now, speaking of next test, and we'll go over the quiz in just a minute, I would like to, can you guys scooch back a little bit, please? I would like to show you what we have going over here. Ready? Take a look. Today we have lesson 11. Tomorrow, oh, this is it, lesson 11. Tomorrow we have lesson 12. And then we have lesson 13. Now, next week, we are going to do a pre-learn packet on Monday, Tuesday. We have no school on Wednesday. Parent-teacher conferences.
I can turn up.
And then on Thursday. Then on Friday, you're going to have a full period quiz. It'll be longer than usual, and you will not get 3 tries. 1 try only. I'll grade it and return it to you, and your homework will be to do the corrections on the quiz. So, if you get a really high grade on the quiz, you have very little homework. If you get a low grade on the quiz, you have a lot of homework. Yes?
How many questions?
I haven't made up my mind yet because I haven't made the quiz yet. I just wrote myself a note on my laptop that tonight when I'm doing some home teaching to make up the pre-learn packet.
How many questions do you think about?
It depends how many of them are graphs, because graphs take a little longer. And then we'll come back and we have a pre-test, and a test. Then we will do a relearn packet, and the pre-test, and then another test. So as you can tell, the next couple of weeks are really important, and you're gonna have 2 tests on back-to-back Wednesdays that are gonna be all about the material that was on the quiz today, and the material that's on the Do It, and the last thing you need to learn is the topic we cover the next 3 days, which is taking what we already know and moving it into real-life problems. So, do the quiz now. No, nobody's going to the bathroom. I'm tired. Listen, guys, you are grown. Not completely up, but you're grown enough that you know when you have a class coming up, you can go to the bathroom. Now, if you were outside running around like crazy all period, I could kind of get it. Because then you're rushed when you get back in. But you just had 40 minutes to go. So if you were done with your Do It and we hadn't started the lesson yet, I'd let you go to the bathroom. But we have a lesson to learn right now. What is the slope of a line? Connecting the points. -1, 1, and 1, 6. So here's -1, 1, and here is 1, 6. So the question is, what is the slope of the line that connects those points? I'm going to go up what? 1, 2, 3, 4, 5. Over 2. So the slope of the line that connects them is 5 over 2. If you wanted to use the slope formula, there it is. It says the 2 coordinates are -1, 1, 1, 6. We'll let this be the first point, this be the second point. So the formula says the y from the second point. What is the y from the second point? Talk to me, guys. Y from the second point. What is it? 6. Come on, more participation. What's the y from the first point? We'll sit here all period until I hear the whole class saying it. What's the y from the second point?
1.
1. Very good. What's the x from the first point?
-1.
All right, so I'll put it here. I asked it out of order. And what's the x from the second point?
1.
1 it is. Circle agregar. 6 minus 1 is 5. 1 plus 1 is 2. So whether I do it with the formula or if I draw it and count it, either way, I come up with the same exact value for the slope. Next question. We have a line y equals 3x minus 7, and that's parallel. Then we have the same y-intercept, this is like the one we did a minute ago, as y equals 1/2 x plus 2. So here's my new line, y equals box x box. So somebody tell me either the slope or the y-intercept, I don't care which one. Somebody tell me slope or y-intercept. Ishi, stop doing homework.
4.
Okay, what do we got, Stephen?
Slope is 3x.
Just 3. The x is never part of the slope. So the slope is 3 because it's parallel. Parallel lines have the same slope. And Ethan, what is the y-intercept?
4.
I'm sorry, what? No, well, that's for this line, but I want the y-intercept from the other line. Positive 2, very good. So y equals 3x plus 2 is the correct answer. Next up. I sense distraction. Is there something I'm missing here, guys? Next up. Hey, can we stop? 3y equals x plus 6. And now it says, what's the slope and the y-intercept? And almost everybody in the room, just about everybody, realizes when you look at this, the problem is it says 3y equals. What is it supposed to say?
Y equals.
Y equals. So you have to divide by 3 first. And the one thing that a couple of people are still messing up on here a little bit. What number is in front of the x, though I don't bother to write it?
1.
1. So when I ask you what is the slope, it's not 3, it's 1/3. Okay? Because it's a 1 over 3. 1 over 3. Next, what is the y-intercept? 6 divided by 3 is 2. Okay? And then the last part of the problem was to graph this, and the graphing looked very good, with rare exception. The graphing looked, in fact, I would say borderline excellent. The y-intercept is 2, so I begin at 2, and then it's up 1 over 3, up 1 over 3, up 1 over 3. Backside a little bit there. And there is my graph. Okay? Any questions? All right. So, this is a, if you were to ask me, what is it about the Common Core? What is it in the Common Core that happens, that does things, etc.? what's the difference? What is the big thing about the Common Core now compared to what kids used to learn? Well, for 8th grade, there's one particular difference. For the most part, you now do a lot of types of questions that we used to do in 9th grade. So when you look at an accelerated student, Gab, and you say to yourself, man, there's an honors kid, they're really smart, they're doing this stuff a year early, you should understand that most of you are also doing this stuff a year early. They're doing the stuff, for the most part, that's actually in a lot of ways, not completely true, but a year and a half to 2 years early. But you are as accelerated as most kids were 5 years ago. Next, Common Core doesn't really care about the aesthetics of something. They don't really care about truth. They don't really care about learning for learning's sake. Everything in the Common Core is how do we apply it to real life? How do we apply it to business? How do we apply it to making money? That's what the Common Core really likes. They dig deeper and they apply it to real life. They dig deeper and they apply it to real life. So what we're about to do for the next 3 days, and then it will be on all of those pre-learn pages that you do, and the pre-test, and the full period quiz, and everything else that's going to be going on for the next couple of weeks after this. We're really going to slow down and dig deep and make sure that we know what we're doing. All of that material is all about real-world applications. So, without any further ado, let's do some real-world stuff. Ready? Mrs. Wilson's oven increases in temperature at a constant rate. I'm actually going to want to go to 75%. Good. Mrs. Wilson's oven increases in temperature at a constant rate. Now, constant rate is a code word. Ready? Constant rate in terms of graphing, and we have a graph there, so we know we're going to have to graph, means straight line. So as soon as you see constant rate, you should be thinking linear, straight line. After 5 minutes, the oven temperature is 150 degrees. After 10 minutes, it should say the oven temperature, not the room temperature. My God, if the room temperature was 200, we'd be dying. The oven temperature is 200 degrees. In the space below, graph the line representing the change in temperature over the first 15 minutes. So, the axis for time is input. The input axis is always the x-axis. So this is going to be time. And I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Why don't you set that up on your paper first? Okay. And make sure you also put time on there. Time is very important. Okay. Now, 150 and 200 degrees. Does it make any sense to go 1, 2, 3, 4, 5? No. You'd be way up past the ceiling by the time you hit 150. So, we have to pick a number to go up by. What do you want to go up by? 50? 50 is a little big. Well, let's go 10s. Let's try 10s, okay? 5 was the other option. I would have thought about 5 or 10, but let's go 10 and see how that works.
150 and
10,
200.
20, 30, 40, 50. It's getting a little crowded, so I'll just go 60, 70, 80, 90, 100. 10, 20, 30, 40, 50. 60, 70, 80, 90, 200. 10, 20, 30, 40, 250. 60, 70, 80, 90, 300. and this is temperature. And this will be all about oven temps. So the first thing is when I set up my graph, it's very important that I put on it what we call a scale. By scale, that's the 10, 20, 30, 40, 50. So that whoever's looking at your paper understands what these numbers actually mean. They don't mean 1, 2, 3, 4, 5. It's also important that you label everything there are. The graph is about oven temperatures. This here is the time, and this over here on the left is the temperature. So you get all of that set up before you even attempt to graph the thing. Okay, are we good? Now, any point on a graph is usually XY, okay? But in this case, we don't have an x-axis and the y-axis. What do we have in this case?
The bar graph?
No, it's not going to be a bar graph, not at all. What is the x-axis called in this problem? Instead of calling it x, what do we call it?
Time?
Time. And what is the y-axis called? Instead of time, instead of y, it's called temperature. So any point is time, comma, temperature. So that's what I'm going to graph. Now the first thing I notice is, after 5 minutes, the temperature is 150. So on your paper, mark where 5 minutes is 150 degrees. Go ahead. Okay, ready? 5 minutes. 1, 2, 3, 4, 5. 150. Right there. Now, what's the next important point to mark? Somebody else, somebody help me out here. Angela and Rachel have helped me a lot. I want somebody else to help me out.
10 and 200.
10 and 200. So here's 10 minutes. 6, 7, 8, 9, 10. And now 200, which is right here. All right. Now, we gotta be careful when we figure out the slope. Let's do the slope in terms of boxes. How many do I go up and how many do I go over to go from here to here? Up how many? 5.
5.
And how many do I go over? 5. So 5 over 5 is a slope of 1, and that's just in terms of boxes. So let me put up 1 over 1. Oh, look, it keeps on right going. Oh, that's perfect. And it said to do it all the way up until I'm at 15 minutes, which is there. And now I'm going to do the backside, just like I learned on the other graph. Now, there's my dots. What do I have to do next?
And I'm,
But, whoa! There's no arrow on the left, and there's no arrow on the right. Because it only said go to 15 minutes. And you can't have an arrow on the left, because can you have negative time? No. So I start at 0, and I go up to 15 minutes, because that's what it told me to do. And there's my graph. Okay? What's the y-intercept?
The number that
Well, in general, sure, it's the number that where it crosses the line. On this graph, what is the y-intercept?
100.
100, excellent. So if I said to you, what is the equation for this graph? We would go with y equals box x box. So what's the slope?
5 over 5.
No,
1 over 1.
no. Careful. How much does every box up represent? How much does every box up represent?
Oh.
No, every box represents 10. So if you remember before, I said, let's do the slope, and then I kept saying, in terms of boxes, in terms of boxes, in terms of boxes. And for boxes, it's up 1 over 1. But what is every single box worth? 10. So the whole slope is up 10 over 1. And now, what's the y-intercept again?
100.
So plus
100.
100. Now, what's really cool about this is I could figure out any value. For instance, let's figure out what's the value at 12 minutes. So let's plug in a 12. What's 10 times 12? 120, right?
24.
And what's 120 plus 100? 220. Now let's check this out. This is pretty cool. Ready? I like this. Here's 12. Where am I at on the graph? I'm at 220. Right? Because here's 200, 210, 220. So I could find the values by looking at the graph, or I can find the values by plugging them into the equation. Just by looking at the graph, just look at the graph, don't plug it in. What is the temperature at the 8-minute mark? Look at your graph. What is the temperature 8 minutes into the oven heating?
180.
Figure it out. Let's see. 8 minutes in, ladies. 8 minutes in, what is the temperature going to be? 5, 6, 7, 8. 180 it is. Now, plug in an 8 here for the time, and let's see what you compute. See if you also come out with 180 that way. Plug in an 8 for x, because 10 times x. You could even, if you wanted to, you could even put a t there for time. Doesn't make a difference. And see what we get out of the deal. Okay? Plug it in, see if you come up with 180. Plug in 8 for t or 8 for x, whatever variable you want to call it, and see if you come up with 180. Because we got 180 by looking at the graph. I want to see that it works both ways. Oh, if you don't know what 10 times 8 is, tell them. I was just going to say, I know you're better than that.
Now I see.
Okay, ready? Y equals
Yeah,
10 times 8 plus 100. 10 times 8 is 80, plus 100 is
oh my.
180. So whether I get it here or whether I look it on the graph, I can figure out 180 either way. Okay, can I tell you something? To me, that is what I really, really like about this. Let me just give you a little, for instance, on history. History, it can be argued so many different points of view. I was on Facebook last night talking to a friend of mine from Europe, and he said to me that Americans don't understand European history and the bloodbaths that have been going on in European history. That's what he told me. And I said, well, I can understand them in a cognitive sense, but I wasn't there. And I said something like, have you seen the movie Saving Private Ryan? Did anybody ever see that movie? Okay. Do you remember the scene where they stormed the beach at Normandy?
Yeah.
Like, everybody always knows about D-Day. Everybody knows we launched this big invasion. When you watch that scene, didn't it mean so much more to you than before you ever saw that scene? With the bullets whizzing by and all the structures and so on and so forth. So that brought it home more. Now, his point was with respect, and I'm sure you've seen it in the news. If you haven't, you really do need to know a little bit more about the world. The Syrian refugee crisis, and he was talking about the refugees flooding up into Europe and how in his area they don't want them because years and years and years of battling with the people from the Middle East coming into his area. And he says, it's always war, it's always fights. He says America doesn't understand it. So there's the American point of view on that, and then there's the European point of view on that. But in math, if you want to take the point of view where, you know what, I'm going to look at my graph, and when I'm done looking at my graph, I'm going to get the answer. Or if you say, yeah, I'm not big on graphing, but I'm really good with algebra and numbers, so I can just plug the number in. Well, whichever way you want to do it, you're going to come up with the same answer. And to me, that's a really comforting thing. Another way would be to say, well, I know it goes up 10 degrees a minute. If I start at 100 and I go 8 minutes, it's 110, 120, 130, 140, 150, 160, 170, 180. Hey, I could even do it counting on my fingers, and I'm going to come up with 180. So, okay. All right, so we did the 12 minutes. Instead of 18 minutes, we did 8 minutes. That's not a problem. Okay, so I want you to do this one alone, or I should say with the people sitting around you. I made this question a few years ago when Gibbs was a young puppy, and he was gaining a whole lot of weight. So let's graph Gibbs's weight gain. Go ahead, do it. Come on, let's go. Work on Gibbs's weight gain here.
At 8 weeks old, he was weighing 50 pounds. At 10 weeks,
I want on there.
Caitlin, let's get graphing here.
I think this is a really nice
All right, you gotta set up an appropriate scale. You gotta have time across the bottom. We have to have weight on the left, like where the y-axis is.